Hey everyone, so let us focus on problem number 3 for day 1. And today's problem is problem number 76 on LeetCode, which is minimum window substring. And it is a hard problem. So we'll give a bit more time to this and try to investigate and arrive to its solution, okay? So the problem states that we have been given two string S and T, and we have to return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, then we return the empty string and the test cases will be generated such that the answer is unique. So this is the example. I want you to take a look at this example, and now let us move to the dashboard where we will try to investigate and solve it. Now, so we have been given, let us suppose, a string t, and we have been given a string s, and we have to return the length of the minimum, not the length, the actual minimum substring of s, such that it contains every single character that is present in t. Note this thing that the order of character do not matter. For example, since the order here is ABC and our actual answer will be PANC, okay? And this is the minimum answer that we have to return. You notice that the order do not matter, right? B came before A, and A came after B, but here the order was pretty much different. We just have to look at the frequency or the actual material of T and whether they are present in S or not. And we have to return the minimum window substring of S that fulfills this criteria. The criteria once again is that we have S has to have every character in T, including duplicates. All right. How do we solve this problem? We solve this problem using sliding window, which is an optimal approach. But the brute force approach would be to generate every single substring, which will take us down to the path of order of quadratic, which is something that we definitely want to avoid in this case. And so we will try to stick to this problem and try to solve it using sliding window. Okay. Now, using sliding window, the first step that we need to do is how do we make sure that our window encompass every single character present in T? How do we do that efficiently? One of the ways to do that efficiently is to have a hash set for T and make a comparison with the hash set or dictionary of S, correct? So that is what we are trying to do in line number 1 here. What we do is we generate a counter. Counter is a Python word here. What it does is it basically generates the frequency key value pair in terms of frequency and the actual character of every single character. It is like a dictionary, okay? And it is something that we'll need later on. In the next step, what do we do? We generate another empty dictionary, which will store the frequency of every character presented as. Now, there are two things. The question is stated that we have to have a minimum window length such that minimum window length of the substring such that it contains every single character of T. Now, how do we make sure that this window will contain every single character of T? One of the ways is to look at the dictionary, okay? But what can be a much more convenient way, a much more mathematical way? It would be to keep the count of the number of unique characters present or in T, right? So that is what we are doing over here. We declare a variable called as need, and it will encompass the length. Length means it will give me the unique characters present in T, correct? And it is something that we need. So I have named it need, and there is something which is something that we require, which is something that we demand from S, and which is something that we require out of S, correct? And so there is a different variable, and I have called this have. I could have renamed it as demand or something, but have seems to be much more convenient here. Okay, and it will make much more sense as we proceed. Initially, have is empty. Have is initialized to 0. Why? Because our count as container as dictionary is empty, correct? And we also declared few other variables. The one of the important variable is left, which is the left pointer, and this is the result length. Why it is important to declare result length as infinity? Because we target to achieve the minimal length of the substring, and the result length here implies the length of the substring. Initially, it is set to infinity, and it will make much more sense as I show you the code why so. And result, this will also make much more sense as we walk through the code. Okay. Now, what do? We keep a separate iterator called as write as here, and we try to loop across the length of the entire string s. And as we do that, our entire time complexity for this case up to now will be order of n. In the first step, what do we do? In the container of s, which was a dictionary over here, we add the string value, character value presented as of right. We add it to that part, and we should increase the frequency by 1. Okay. And once we add the character in the container of s, once we add the character in the container of s, okay, suppose this character goes in the container of s, we ask, hey, is this character also present in container of t? Hmm? We ask ourselves, hey, is this also present in container of t? And if it is present in the container of t, are there frequency of character C in container T, is it equivalent to the frequency of C in container S? If that is the case, then we are pretty much sure. We have a sure shot here that this character C, if it has a frequency of Fi in container of S, the same character C, if it has a frequency of Fi in continuity, it means one of our material has been materialized, as in one of the character that we look for, our demand actually, it has been materialized. So what we'll do, we'll increase our have by 1. Okay. I mean, let us initially see, we declared a need variable, right? Let us suppose need will be some character count, let us suppose k. Our objective here is to increase have step by step, progressively until it reaches key, until it reaches k. And once that happens, we will be pretty much sure that the window reached at that stage will have the entire character of t present somewhere arbitrarily distributed within that window. Okay. And the only thing at that stage that would be left for us to do would be to shrink the size of the window from left so that we acquire or we reach a stable minimal window length. That would be our answer. All right. So after this step, what do we check? We check, hey, is the need, is it equivalent to have? If it is the case, if we reach such a state where our need and haves are equal, in that case, we make a check for the length. Why are we making a check for the length? We are making a check for the length because we have to return the minimum window substring. Remember that, okay? And that is why we compare it with the initial result length. This result length initially, as you can see here, it signified infinity, and it is nothing but the actual length of a window string. Okay, so we compare it with the old length of our window, and if that is acceptable, as in if the current length of the window, if it is less than the old length of the window, in that case, what we'll do, we'll first of all update the old length, and then we will assign the pointer left and right. See, when we reach at this stage, our left and right pointer, they must be at some arbitrarily different state, right? Let us suppose L is here and R is here, right? So we want to capture that thing. So that is why I have captured it in the list of length 2. The first is left, the second is right, and that goes in the result variable. Okay. Now, once I do that, once I capture the state, what is the next thing that is left for us to do? The next thing that is left for us to do is we see first of all here that we are within this loop where need and haves are equal. I told you above that if our needs and haves are equal, the only thing that is left for us is to shrink the size of the window from the left, correct? So what are we trying to do over here is, since we store all those vital informations by comparing the length, and since we are within this loop where needs and haves are equal, right? What do? We discard the left character and reduce its frequency by 1, okay? In sliding window, when do we move left? We move left when a condition is violated or when we try to reach to the acquired or the required solution. Okay, in that case, we move left to the right. Before moving left to the right, what do? Decrease the value of the character present at left by 1. And when I did that, I asked, hey, when I decrease the value of this character, Is this character also present in T, container of T? Is this character also present in container of T? I asked that thing here. And then I asked, hey, if that is the case, if I have reduced the left portion by one, left character portion by one, and if that is present in container of T, what if the container of T, the frequency of that character in container of T, what if that exceeds the frequency of the character in container of S? It means, let us suppose it has like 1, 2, 3, 4 in container of T, and in container of S, it is just like 3, okay? Once it has been reduced to 1. So we see that this has a higher frequency. So once that is the case, we were in loop where our needs and halves were equal, right? But since we chopped a portion out of container of S, as you can see over here, that is what we were doing, right? It is container of S, okay? Since we have chopped a portion out of that, this balance has been, this balance has been shifted to container of T. And in that case, if the container of T is higher frequency than container of S for that specific character whose value was reduced over here, in that case, our hab will be in an imbalanced state by 1. Okay, so that is why we have reduced the value of hab by 1. And once we do that, we shift our left pointer to the right by 1. That is what we are doing. And this is being done in the same loop. Okay, now notice one thing. You might think that, hey, so it looks to me that this loop will only run once because this imbalance is getting created over here. The answer is no. This loop will not run just for once. Why? Because what if for this imbalance to be created, this condition must first of all has to be executed, correct? What if this imbalance is not created? What if the character that we are chopping on the left, what if that character is not present in container of T, correct? What if that character is some random noise, which we don't really care about? What if that character is some arbitrary character not present in the container of T? So in that case, what will happen is this line will not be executed and this imbalance will never be created, okay? And we can easily move our left. And eventually, what we can do is we can shrink the window size consecutively as long as this imbalance is not getting created, okay? And once we are done with all those things, we will break out of the main loop, this is out of the main loop, and we will unpack the value stored in the result list, which was nothing but the left and the right pointer at the state when haves and needs were equal, right? At this state, correct? Let me use a red marker. At this state, right? When halves and needs were equal, result was stored in this part and the length was updated, right? So that is what is happening here. We are just unpacking that from the list, the two pointer left and right. And then what we do in Python, when we slice a substring, the right part is not exclusive, the right part is not inclusive. So we include it by adding +1. Okay, so in that case, it is much more like saying left to right. Okay, where both are inclusive. Right plus one means right plus one will not be included, just the right index will be included, okay? Starting from the left. And we ask if the real length is not equal to infinity, then return this. It is just a Pythonic line, and else we return empty if result length is equivalent to infinity. So yeah, that was the entire code. And if you look at the time complexity, you would notice that initially this was of order of n, the main loop, okay? But within the main loop, we have something which is like a gain, which will go to order of some, I don't know, theta, not theta. Let me just put, not k, I can put it k. Let me just put it some constant, not constant, z, okay? So it will be around quadratic, okay, but not quadratic. It will be bounded by that thing. It will like order of n times order of z. And what is z here? Z depends upon how many times can we have need equivalent to have, right? So yeah, that's it. Actually, if you try to investigate more on this thing, then you will realize that z is nothing but it is directly linked with the length of t, okay? So this is nothing but the length of t. All right. So yeah, and this is nothing but the length of s, correct? So yeah, that is, and space complexity, as far as space complexity is concerned, it should be order of n or length of t and length of s, right? So yeah, like I will just consider to be linear order of n space, and the time complexity is this thing here, right? And what are the edge cases for this problem? The edge cases for this problem can be that we need to make sure, what if the length of t is greater than length of s? If that happens, it means t, entire t cannot be a part of s, right? Entire t cannot be a part of s. Or what if s is empty or and t is empty? So that can be also one of the edge cases, right? So we have to take a look at all those edge cases before we try to solve this problem. But fortunately, in this case, I don't think that will be a trouble because that has been handled, okay? I mean, in the problem itself, okay? I mean, we will not be given an example where this will be the case, I think. So we don't need to worry about that. But again, this is what it is. I hope you understood everything that I tried to explain you over here. And now let us move back to the LeetCode dashboard. I don't really want to go through the dry run of this problem because it will be really exhaustive. But again, it can be done. If you understood the code, what I was trying to explain, I would encourage you to try it on your own. And I'm pretty sure you'll be able to do it. But in case if you want me to do a dry run for this thing, I'll make a separate video, or you can put in a comment that you're not able to do it, and I will help you. Okay. Let us move to the lead code now. So this is the lead code, and I have written the code, I'll just paste it and I will try to run it. Okay. So this is the code. Let me show you. This is the entire code, okay? And I will run it. And as you can see, it should pass the test cases. And it has, okay? So yeah, that is what it is all about. It was a really, really interesting problem. And we will be tackling more difficult problems along the way. This was the third problem for today. And I hope you will stick with me for the upcoming problems, which will be again a mix of medium and hard problems. Let us go.